All right, so we're going to talk about geometric mean today. What geometric mean, the things that we're going to be focusing on here is how we can use it to find missing measures in right triangles. Okay, so again, this unit is mostly for right triangles, so that's what we're going to be using. We're going to be using methods to solve for missing things in right triangles, and this is going to be one of them. Okay, so what is the geometric mean? Okay, this is one of the definitions that we could use for it. It's just the nth root of the product of n numbers. The nth root of the product of n numbers. Okay, you could also think of it as a square root of the product of two numbers. So to further understand this, we'll go ahead and take a look at some examples that show us what we're going to be looking at and how to solve the geometric means. Okay, so what we need to do here is we need to find the geometric mean for each one of these examples, or each one of these set of numbers. Okay, so it's always going to be a set of two numbers that we're working with here. So this right here, the Google for Simplify Radicals calculator, that's the calculator that we've used in Desmos. We don't need to go and find another one. The one in Desmos is perfectly fine. Oops. Okay, but the first thing that we need to do is we do need to find the geometric mean for these two numbers. Okay, so coming back here to our definition and what it means, the nth roots, okay, of n numbers. Okay, let's just say that I have a set of three numbers. Okay, so three numbers like this. It can be any three numbers. It doesn't matter what three numbers. But if I have three numbers that I'm working with here, the nth root of three numbers is just going to be the third root. So the third root, the way that would look is like this. Okay, so this is what it'd be for three numbers. If you had four numbers, you would go to the fourth root, and it would look like this. Okay, but for us specifically, okay, that's what this little line right here means. Okay, we're only going to be focusing on two numbers. So every set, just like we saw in some of those examples, every set's just going to be a set of two numbers. So for us, that's going to be the second root, and it's what we focused on when we did our radicals review. Okay, so you can write it like this. You can put the 2 here, but you don't really need the 2 because it's assumed that with the square root that we're going to the second root or taking the 1/2 power. Okay, so that's what this is talking about. The second part of this, okay, is the product of two numbers. So product is simply just multiplying. So when we come here to our examples, okay, all we're doing is we're taking the nth root, okay, since we have two numbers, we're taking the square root, the second root. So the way that I would set this up, if I'm doing this example with 2 and 8, is I'll do my square root symbol. And then underneath it, I have the product of the two numbers. So the product is just multiplying. So what I have to do underneath the square root here is multiply the 2 and the 8 together. And then from there, it's just simplification. So 2 times 8 is 16. So for this specific set, I'm taking the square root of 16. And then this is where the calculator comes in handy. Talking about the calculator in Desmos, okay? You can type this into that calculator, and what it would give us is 4. And we don't we're not going to write the plus and the minus. We're only going to keep it as positives because when we're talking about links, okay, we don't really care to have negative links. There's no such thing. So for this specific one, the geometric mean of these two numbers is going to be 4. Okay, we'll do one more example, and then I'll let you try the last one on your own. I'll tell you what, I'll let you try this middle one on your own. We'll do this last one here together. Okay, so same thing, we have two numbers. So we're taking the square root. Inside I have 4 times 6. I have the product of 4 times 6. Okay, so that's going to give me the square root of 24. Now, when you plug this into a radical expression calculator, it's not going to give you, it's going to give you a decimal. It's not going to give you the whole numbers like we did up here with this 4. Okay, so for this 24, okay, this is where we'd have to use a prime factorization method. Okay, so we always start with the lowest prime factor, which is 2. 24 divided by 2 gives me 12. Divided by 2 again. 12 divided by 2 gives me 6. And then 6 is 2 times 3. So here, the only thing that I can do at this point is circle one set of 2's. And then I pull that out. And then the 2 and the 3 down here are left underneath the square root symbol. So then this 24 becomes 2 because we pulled a set of 2's out from underneath the square root. And then underneath, I still have the 2 and the 3. And since we can't combine these together, we can just leave this as a 6. Okay, so I'll let you try the 4 and the 9 on your own. All right, so we have this example right here. This is just an example with 3 numbers, so we can still solve this, but this isn't going to be as likely to see on some of your questions as like the ones with the 2's. So we'll go ahead and do this one real quick. Okay, nothing changes the way that we set it up, and the only difference is now we have 3 numbers and we have to take the third root of the products. So here I'm going to multiply 2, 4, and 8 together. 2 times 4 is 8. 8 times 8 gives us 64. Okay, notice we're not taking the square root. Okay, so I have to find some number that when I multiply that number by itself 3 times, I get 64. Okay, so for me, I kind of just know some of these off the top of my head. 4 times 4 times 4 ends up giving me 16 times 4, which is equal to 64. So the cubed root of 64 is going to be a 4. Okay, so if you have 3 numbers like we have here in this example, it's best to use a radicals calculator, but we're not going to focus too much on these that have 3 numbers. The geometric mean that we're going to be focused on is mainly just going to be sets of 2 numbers. Okay, so this geometric mean similarity theorem, okay, we're not going to spend too much time on similarity, but we do need to discuss it. Okay, so what we're saying here is that CD, okay, so this segment CD right over here is the altitude to the hypotenuse AB. Okay, so AB's down here. I know we haven't talked a lot about what these words mean, but altitude is just saying that going from C to D, okay, this segment is the longest segment that connects A and B together from this vertex straight down, okay? And then we have this 90-degree angle here. Okay, so because we have this, we can say triangle ABC, okay? So this large triangle here is similar to triangle ACD, so this right triangle that the altitude creates. And then both of these are similar to triangle CBD. Okay, so that's what this squiggly means. The squiggly just means similar to. Remember, if we have the squiggly with the equal sign underneath, that guy means congruent. So the squiggly just means similar. All right, so continuing our talk about the geometric mean altitude, what we're doing with this is we are taking the altitude that's drawn to the hypotenuse of a right triangle. Okay, so in this example here, that would be this green piece from C to D. So we're talking about this little segment right here. Okay, and what it does is it separates the hypotenuse, okay, the longest side. Remember, the hypotenuse is the side that's across from the 90-degree angle. So it separates the hypotenuse into two segments. So that way, this relationship exists. Okay, so this is the relationship that we're talking about. What I'll do is I'll show you how to manipulate this to get this guy, because the relationship right here where h is equal to the square root of x times y comes from this equation. So when you're manipulating it, you should have learned the, I think a lot of people learn the butterfly method. So it's where you circle the variables like this and like this diagonally, and then you multiply them together and then set them equal to each other. So on one side, we would have h times h, and then that would be equal to x times y. H times h is just h squared, and then that's going to be equal to x times y. And to get 1h by itself, right, because the 1h is just this length that we're looking for, we take the square root on both sides of the equation, and then this cancels out, and we're left with h is equal to the square root of x times y. Okay, so that's when we're trying to find the length for this altitude. Okay, now we also have another relationship. So this piece down here, what we're doing is we are finding this length A. Okay, and the way that we do that is we would have to set up a different formula. Okay, and this one is going to be C divided by A. That's equal to A divided by Y. Okay, so C is this long piece down here. C is the hypotenuse. Okay, that's just it's a general notation that we're always going to use. C is always going to be the letter for the hypotenuse. Okay. Now, when this altitude breaks this the hypotenuse into the two different pieces, what we can do is we can set up different fractions. So here we're just trying to find this length CB. And to do that, we have to use the large triangle and then the small triangle. So C is this long length down here. It's the hypotenuse. So if I wrote this in words, I'd have the hypotenuse of the large triangle, and then that's going to be divided by just one of the legs, the leg that I'm looking for. Okay. And then when I choose my other triangle, I'm choosing the hypotenuse on the other triangle that I'm looking for. So when I'm looking for this length A goes with this triangle right here, CBD. So I take the hypotenuse of the other triangle and I divide that by the leg. Okay, and that leg is going to be down here where Y is. Okay, so that's how we come up with this formula. And when you do the multiplication to get A equals the square root of YC, it's just the same steps as here. But the way that this is explained, notice the hypotenuse of both triangles is on the top, and it's being divided by the leg on the bottom for both. All right, so here's a table that would be helpful, a little bit helpful for you. So this table right here is the same table here, but we're just going to be filling it in for this triangle, okay? So the first thing that we're doing is we're taking a look at this largest triangle. Okay, so the shortest leg, okay, number one, legs are always connected to the 90-degree angle. So the shortest leg in this case is going to be B. The long leg is going to be side A because it's longer than B and it's connected to the 90-degree angle. And then our hypotenuse is going to be across from the 90 degrees. So the hypotenuse is this entire length. This entire length is C plus D. Okay, I do that for every single triangle that I have here. So this green triangle, okay, we're going to put that in this middle box. The short leg is going to be E. The long leg is C. Hypotenuse is across from the 90-degree angle, which is A. I do the same thing for this orange one. Short leg is D, long leg is E, hypotenuse is B. Okay, so this may be something that would help you out. There's always going to be 3 triangles when we're doing stuff like this. Start with the largest one. You can go to the next largest size and then the smallest size after that. Okay, so here's an example that we will work through. Okay, our goal here is to find X. So we don't know, this is how we use the table. Okay, we don't know what the short leg and the long leg is for this large triangle here, but we do know what the hypotenuse is. It's 20. Okay. For the second largest triangle, okay, so that would be this one here. Okay, the short leg is going to be X. The long leg is 16. We don't know the hypotenuse. For the smallest triangle, we know that the short leg is 4, the long leg is X, and then we don't know what the hypotenuse is. Okay, so to use the geometric mean theorem, we need to make sure that we select values or that we select 2 triangles to use that both contain X, right? Because X is what we're looking for. So when I look at my table, this is one of the reasons why it's good to fill in the table. Okay, this one has no X. Okay, so if there's no X, then we're not going to use it. Okay, we have an X here for the blue one. And then for this green one that I'm going to write down, this one also has X. All right, so now that we have the two triangles that we're going to use, okay, we're going to use the blue one and the green one. Okay, the next piece is setting up the proper equation. So from the blue one, I always like to put x on the top. So for the blue triangle, x is the short leg. So the short leg is going to go on the top. Okay, and then on the bottom, I have to use a number. Okay, so in this case, we have to use the 16, which is the long leg. Okay, now I set this equal to the same thing from the green triangle. So I have to do the short on the top and then the long on the bottom. So the short is going to be the 4, and then on the bottom we have the x. Okay, so that's what all of this up here is saying. Okay, so you're just matching up the correct sides together. And from here, it's just plug and chug, solving for x, right? So you can either write it like this, or you can use the other equation, which would be x is equal to the square root of 4 times 16. That's going to give you the square root of 64, which is equal to 8. All right, so we'll pause here, and I'll let you work on this one by yourself. Okay, the first thing that we need to do is we need to fill in the table. Okay, so what I want you to do is I want you to tell me what the short leg, long leg, and the hypotenuse are for the largest triangle. Okay, so here we filled in a purple triangle just with what we have here. Okay, so there's two legs that we don't have, right? And they're the question marks. So the 2 legs, when I come in to fill in the table, the short leg, we don't know, and we don't know the long leg. The only thing that we know is the hypotenuse. The hypotenuse is this 5 plus x, okay, because it's the entire length here. So that's the only thing that we can fill in here. Okay, so since we have 2 question marks in this large piece, are we going to be able to use the large triangle to figure out what x is? Probably not, right? Because for us to use a portion of the triangle, we have to know 2 side lengths. So we're going to move on to a different triangle. Okay, so in green, I've got this small triangle here. Okay, so let's go ahead and fill in some of the values for the small triangle. Okay, so the small triangle is filled in. If you're just looking at the green and all the sides that make up the green, it's pretty easy to identify what the short and the long pieces are for the legs just because of the values here. And the question mark is for the hypotenuse. Okay, so the last thing that we need to do is figure out what this medium size is. So we'll do the medium size in the middle, and then this one will be in blue. Okay, so the sides that make up the blue, we have the 8, we have an X, and then we have a question mark. Okay, right off the bat, we can go ahead and fill in the question mark for the hypotenuse because it's across from the 90-degree angle. That leaves us with the 8 and the X. Okay, so just by looking at these two, okay, you can analyze that the 8 is smaller than the X. So the short leg is going to be 8. The long leg is going to be X. All right, so what I need you to do now is tell me what the formula would be. The formula is going to be for the geometric mean to figure out what X is. So it's going to be a set of 2 fractions set equal to each other. Okay, so here's our equation. what we're doing is we're just taking all the values that we know. So we know these 4 values, the 8, 5, the x, and the 8. Okay, we can't do anything with these question marks, so we just leave those out. So on the top of both of my fractions here, I'm going to put the short piece. So the short piece for the blue is 8, and then the long piece is going to go underneath. That's going to be the x. And do the same thing with the green. Add the short piece for the green, which is 5, the long piece for the green, which is 8. Now from here, it's just solving an equation. We're just simplifying, solving for x. So on one side, I have 5 times x, and that's equal to 8 times 8. And that gives us an answer of 12.5.